Okay, here we go. So, on that first one, inverse sine has got rules. Inverse sine is similar to circle trig, where you would have written this, but, and it's a big but, I'll use capital B, but inverse sine is only allowed on that right-hand side, so it can't be here and it can't be here. And since sine is positive or is negative, then it can't be here. So then it has to be here. Then sine is opposite over hypotenuse. And then this side is a 1. And what's across from the root 3? That angle there, reference angle, would be, ooh, did anybody catch that we're in the negative zone? Raise your hand if you had a negative answer. All right, good. Negative pi over 3. Remember how the biggest answer with inverse trig, this is inverse trig, would be pi. So if you tried to give it as 5 pi over 3, I understand what you were thinking, but it would be wrong. All right, moving on to the part B. Part B, I start on the inside here, and I draw this picture. I don't know if you remember me telling you this, but with variables, you just always do it in the first quadrant. Okay? Since there are variables in it, I'm going to use the first quadrant. Cosine is adjacent over hypotenuse. And this last side, don't just assume it's 1. I know I drew it like it looks like it's 1. But it's a square root of x squared has to be bigger than 1 because it's the hypotenuse. So x squared minus 1. You can't have it backwards. Okay. Now, tangent of that is TOA. It's opposite over adjacent, so it's just that. That divided by 1. So square root of x squared minus 1. Raise your hand if you had that one right. Not many people. Okay. Now that you see it, do you feel like you understand it? Okay. All right. Next one. This one. Cosine, this is definitely the toughest one. I'm sure it's the one that probably took you the most time. I would let u equal 3 theta, and then I would just do circle trig on this one. Cosine has to be negative, so all students take calc. This is not an inverse trig question, so I go back to my old rules of where is cosine going to be positive, here and here, so I got to cross them out because it's negative. And then it's got to be here. Cosine is adjacent over hypotenuse, and this one was the negative one. I put it on the 2 just to kind of mess with you, make you think. The 2 can't be negative. Okay, and this is the square root of 3. And once again, we're at a pi over 3 situation, but this time it's a bunch of pi over 3s, 2 pi over 3s to be exact. 2 pi over 3 is your first answer, and the second answer would be down here. 3 pi over 3 is right here, so it's obviously not that, and it's 4 pi over 3. Okay, so then I've got 2 answers. U equals 2 pi over 3 and U equals 4 pi over 3. From there, I have to be smart enough to remember that U is really 3 theta. So I put a 3 theta here. I also have to be smart enough to remember that I should put plus 2 pi k here. Why? Because I need this. This is what I call a term generator. It's going to help me find other answers. Now to solve, I'm going to multiply everything by 1/3, 1/3, 1/3. And if you did this wrong, the best thing you can do for yourself right now is to take good notes and have a good example problem for yourself. Okay, this one really works out to be 2 pi over 9. Plus this one, I personally would like to have the same denominator there. So I'm going to say it would have been 2 pi over 3k, but I'm going to times it by 3 on the top and the bottom, and that'll make it 6 pi over 9. You can do that, and you don't have to. I would have been okay with it the other way, 2 pi over 3. But 6 pi over 9 makes it so much easier to add later. All right, this next one is 4 pi over 9. And then this, again, I can just copy the other one, 6 pi over 9. They'll be the same period, right? So there. Now, if they had said, I want all solutions, I'd be done. These are my two solutions. And when I put the 2 pi k thing there, that's saying I know it could keep going over and over and over. But this one was a between 0 and 2 pi question. Now, I know ahead of time that there would be 2 answers normally, but when you put a 3 there, 6 answers. So what are my 6 answers? The first one, 2 pi over 9. The second one, 4 pi over 9. The first 2 you get that you calculate out. And then this one, this one, this one, and this one come from adding 6 pi over 9, like that, and getting 8 pi over 9. And then this one gives me 10 pi over 9. And then I add another 6 pi over 9, because k is 2 now. I'm doubling it. I like to just add another 6. Okay, so this was the one where I had 8. Now I'm going to add another 6 pi over 9. 8 and 6 is 14 pi over 9. And then this 10 pi over 9, I'm going to add 6 pi over 9 to that. 16 pi over 9. And just to make sure you didn't mess it up, I would go, okay, if I'm in pi over 9s, then the biggest I could have ever gotten was 18 pi over 9. And that's actually too big because you're not supposed to be 2 pi. So as long as I stayed under 18 pi over 9, I was good. And I did. So there we go. That is a serious, hardcore math problem. How many of you are able to pull it off all by yourself? And that's about half the class. And if you didn't, I hope you just see what you did wrong. All right. Any questions about how that happened? If you have a specific question like how'd you get this or that, I'm willing to help. Or maybe I made a mistake. It's humanly possible. But enough people said that they agreed with me that makes me think I'm right. Yes?
In the negative sign in the first question, why do you suddenly do that in negative?
Do you remember that inverse has a bunch of rules? Inverse cosine can only be here to here. Inverse tangent, here to here but doesn't touch. Inverse sine, here to here but does touch. And then do you remember that this is the dead zone? You'll never get an answer there in inverse trig. And last but not least, this, because our restrictions are from pi over 2 to negative pi over 2, you remember that? That's forcing this to be the negative zone. Your answers will always be written, if they're in there, they'll always be written as negative something. Now, other rule you broke, if you didn't use a negative, was pi is the biggest answer you can have. If you ever find yourself giving an answer that's bigger than pi, you're doing it wrong.
Oh, I thought that was 2 pi.
Nope, pi. For inverse trig, pi is the biggest answer. Okay, all right. And if you want another explanation, you and I could talk later. It's about the graphs and how the graphs look. And so there's another reason I can show you why it has to be negative. But all right, moving on to D. Where did I put D? There it is. Okay, this one, square root of both sides. Then this simplifies to absolute value of sine theta. Did you remember the absolute value bars? This is square root of 3 over the square root of 4, which is 2. And that's a classic one. You know those combos. It's probably going to be the 1, 2, root 3 triangle, right? But now I break it into 2 equations because of the absolute value. Sine theta equals root 3 over 2. And sine theta equals negative root 3 over 2. And now I get 2 answers for this and 2 answers for this. And then it asks for all solutions, which is a hint that you got to add the plus 2 pi k thing. All right, so one thing at a time. My sine equation that I'm solving here is positive, and so where is sine positive? All students take calc. Sine's positive on the top 2. So then this one, opposite, over hypotenuse. I had a theme of pi over 3 apparently this time. Pi over 3. And this one would be 2 pi over 3. So far I got 2 answers. Pi over 3, 2 pi over 3. Then I go to these 2. This can't be here and it can't be here because sine's negative. And sine is opposite over hypotenuse. Double checking that. Sine is opposite over hypotenuse. Yep. That's a -1 and that's a 1. Okay, good. And then these are pi over 3 theme. So 1, 2, 3 pi over 3, 4 pi over 3, and 5 pi over 3. So there's my answers. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. But sadly, after all that work, you would have gotten it wrong if you hadn't added one more thing. Plus 2 pi k. After each of them. You can't just say, well, you can replace them all with that one thing. No. If you add 2 pi k, you're going to skip right over 2 pi over 3. So they all need to, all 4 of them are answers, and all 4 of them can be replicated by adding 2 pi k. And if you're thinking that this has a different period, it does not. Look at sine. There's nothing in there that's stretching it or shrinking it or anything. So it is purely 2 pi k. Plus 2 pi k. That was 4 really hard questions, but they all would be fair game on a test someday. And you had a chance to practice it, and the people that were gone today didn't. But hopefully they're watching this video right now and make it up for that. So, all right. Then when you come back from break, we will have basically review on Wednesday, review on Thursday, test on Friday. Okay? There might be something new thrown in on Wednesday, but you'll have plenty of chance to review this. But you do need to get it down. All right. Have a great day.